Could a better tsunami warning system have helped save lives last week in northern Japan? Yes, and that is exactly what we're going to discuss and how that might be achieved right here on the News Hub Extra. Good afternoon and welcome. I'm Simon Constable. Joining me on the set, we have senior science writer Lee Holtz. Thanks for joining us. We've also got Bruce Parker. He's visiting professor at the Center of Maritime Technology at the Stevens Institute, and he's also the author of the recently published The Power of the Sea. Thank you very much for joining us.
Thank you.
Before we get to how we might be able to have a better tsunami warning system, let's first talk about how the current one works and then get to why it's sort of only good as far as it goes. So how's it work now?
Whenever an earthquake happens, and they're happening all the time, there's seismic data that comes from literally thousands of seismometers around the world, and within minutes they can tell exactly where the earthquake took place. If the earthquake took place underwater, which is the only kind that might generate a tsunami, they actually have to determine whether it did, because most of them don't. It has to be a large vertical motion of the sea floor, lifting millions of tons of water to create the tsunami, and many of them don't meet that criteria. So you can't give lots of false alarms. Every time a submarine earthquake happens, you can't give an alarm. So the next step is to detect the tsunami. And classically, it was done with real-time tide gauges, which were mostly around the coast.
Tide gauges, that's what you're saying?
That's the tide. That's the gauge that actually measures the tide itself, the water levels, and that's a much longer period, slower variation than like a 30-minute period tsunami.
Yeah, I mean, if you were at sea, you wouldn't even notice, right?
Well, as a matter of fact, tsunamis like hundreds of miles long in wavelength and only a foot or two high in the deep ocean, traveling at 400 miles per hour. It's only at the coast that it shortens up, it heightens up, and all that power gets concentrated.
And let's recap that. They move at 400 miles an hour.
Out in the open ocean.
In the open ocean.
And then
that
they
is as
slow
fast
up.
as a jet aircraft
Exactly.
going at a cruising speed. That's very fast. So we
But it's
need
not
to,
doing any damage out there.
It's not doing any damage, but it will when it hits the ground, right? Okay, and so that's the issue. It's the time issue. It's the speed at which it moves. And you're saying that we've got to find a way to move to get
just
more.
to clarify the earlier point, first tide gauges detected it, but then that only covered certain places. They came up with these dart buoys, which are huge buoys connected by acoustically to pressure sensors on the bottom, so that in the open ocean with a better spatial coverage, they can detect that a tsunami actually was created. At that point that they know it's real, they can put this information into numerical tsunami models that do very good jobs of predicting where it's going to hit and when. And so they can do very good forecasts for 1, 2, 3, 4, 20 hours into the future. The problem is trying to get a forecast in that first 30 minutes to an hour is very tough. And for example, off Japan, the tsunami started roughly 30 minutes after the first earthquake. And that's no time for a warning, and then it goes back to the awareness, the tsunami awareness of the population. And luckily, the Japanese are very aware of tsunamis. They get hit by them a lot, earthquakes a lot. And so as soon as they see the sea recede, or even before that, even just feeling the ground shake for more than 30 seconds and being next to the ocean, they run for higher floors, they run inland, but 30 minutes is still not much time. And it was even worse in Sumatra. It was 15 minutes before the epicenter part of the earthquake generated tsunami hit Sumatra.
Lee, you look like you want
Well,
to
no, I just was curious that we were talking earlier. Now, we require multi-million-dollar buoys to keep track of this stuff, but there are creatures in the natural world that have a capacity to kind of sense these on their own. Is that true?
Well, you must be speaking of the elephants in particular, because there have been plenty of stories of elephants sensing the tsunami, running for the hills, and frequently saving tourists on their back who didn't know what was going on. And it's not a sixth sense.
No, but how can they do that?
It's called... as I said before, the tsunami's a very long wavelength wave. As it gets into shallow water, it shortens. But that shortened wavelength wave now is making the air above it oscillate at the same wavelength. And it's actually sound waves, but they're low frequency. We can't hear them, but the elephants can.
And they have big ears, and they literally can hear it coming. And so is there a way to sort of get the elephant senses to sort of work for us? I mean, because clearly they've
Well, in
got
fact,
what it
there's a
takes.
second sense that's even upset them before that happened, because the seismic waves from the earthquake itself travel through the earth, and those are like traveling vibrations that are kind of analogous to sound in the solid earth, and they sense them with their feet and even their trunks when they lie them on the ground. So they've already been upset once with the earthquake, and then the tsunami starts coming into shallow water, and they get that infrasound, and now they're really running for the hills. And of course, we can't put elephants everywhere, but scientists can measure infrared sound. I mean, infrasound, low frequency sound. So they've been looking at that as a way of possibly, providing part of the warning.
This is an active research area?
Yes. I'm not sure how much money's been given to it, but there are definitely researchers working on it.
I'm interested that the elephants know enough to run for the hills, because one of the results of the early warning after the most recent Japanese earthquake and the resulting tsunami along the coast of California was that people took advantage of the alarm to run down to the shore so they could see the tsunami. They were very disappointed that it wasn't so high.
Yeah. Well, and unfortunately, of course, the kind of tsunami awareness that you're supposed to be learning about the receding sea is the very thing that attracts people down there who don't know about tsunamis to look at the flapping fish on the dry sea bottom and see the coral heads. And that happened all throughout Sri Lanka and Thailand and Sumatra. The only ones who didn't do that turned out to be the more ancient peoples. And there were groups, the Moken Sea Gypsies of Thailand, the natives of Sumile. The island is actually closest to the epicenter. There's 75,000 people in that island. Only 2 died. They knew to run to the hills because stories have been passed down from generation to generation about this receding sea and feeling the ground shake for a long time.
So it sounds like animal knowledge and ancient knowledge is not to be discarded. We have to leave it there. Thank you very much, Bruce Parker, author of The Power of the Sea and also a visiting professor at the Center of Maritime Technology at the Stevens Institute. Thank you also, Lee Holtz. I'm Simon Constable, and that's it. That's the News Hub for now. We'll be back with more later.